Okay, let's study a new function which is called the exponential function. The exponential function. If you had bacteria, for example, which reproduce every 1 second. When they reproduce, every one bacteria gives me two new bacteria. Okay, they just split in 1 second. So in the next second, we just have each of them will give me another two, and for the next we'll have another two, and so on. So let's count the number of cells, or the number of bacterial cells. In this case, this will be 2. This case will be, I'll just write it to be 2 power 2, and in this case it will just be 2 power 3, and so on. This is 2 power 1, this is 2 power 2, 3 power 3, and so on. Okay, so if you look at this, and also this one, we may write it as 2 power 0. If you look at this function, which describes the number of cells at each time, we are talking here about a discrete time. Okay, so that time is a discrete value, 0, 1, 2, 3, and so on. You will find that the function is described as a constant power the variable. It is described as a constant power the variable. Okay, a constant power the variable. That is exactly the exponential function. This is an example of an exponential function. So an exponential function is a function which is in this form, a power x, and we put a condition that a must be a positive value. Get a condition, a positive value greater than 1. No, we just put that condition just to be a positive. No, just put it like that, a power x. Let's check the conditions afterwards. So this is called an exponential function. This is called the base of the exponential function. The base of the exponential function, and this is the exponent. This is the exponent of the exponential function. Okay, so let's check a power x with the case that a is greater than 1. For example, if we check 2 power x, f of x to be 2 power x. For this case, let's sketch that function. For 2 power 0, it gives me 1. 2 power 0 gives me 1. Then 2 power 1 gives me 2. Then 2 power 2 gives me 2 power 2, which gives me 4. In this case, it will be just up there. 2 power 3 gives me 2 power 3, which is 8. So in this case, that will be the function. For negative values of x, what about the negative values of x? If I need to find 2 power negative 1, that just gives me half. That's in this case gives me half. So for negative 1, it will just give me a value of half. For negative 1, it will just give me a value of half. For negative 2, it will just give me a value which is 1 over 4, and so on. it will just keep lessening like this. It keeps getting smaller and smaller like this. So this is exactly the exponential function. As you see, in this case, when a is greater than 1, the curve is just like that. The curve is just like that. What about if we had a less than 1? So for example, if I had f of x equal to half power x, f of x equal to half power x. So in this case, let's depict that. We have half power 0 is just equal to 1. Half power 1 is just equal to half. So in this case, for the case in the 1 will just give me that number half. Half power 2 will just give me 1 over 4. So in case 2 it will just give me 1 over 4 and so on. So it will just give me a curve like this. For the negative values of x, if I have half power negative 1, half power negative 1 is just equal to 2. And half power negative 2 is just equal to 4 and so on. So for negative 1 I will just get 2. For negative 2 I will just get 4, and so the curve will be just like this. The curve will just be like this. As you notice, what is the difference, or what is the relation between that a power x with a greater than 1 and that a power x but a less than 1? What can you notice the relation between these two curves? They are just the reflected versions of each other. Why is that? Because if you notice, for example, that for 2 power x, what is half power x? What is the relation between half power x and 2 power x? Half power x is just 2 power negative x. Yes? So this function is just a 2 to power x, and this just is 2 power negative x. So what do you do when you replace each x with negative x? What transformation is that called? What is that transformation called? This is called the horizontal reflection. Horizontal reflection. So one of them, making the base to be less than 1, is just a reflection of making the base of the reciprocal of that base. Okay? So taking the reciprocal of the base just makes a horizontal reflection for the curve of the exponential function. And that's why we have in exponential functions, for exponential functions, when the base is greater than 1, if we assume that the base is greater than 1, we have a positive exponential, which is described like this. This is when the power or the exponent is positive. When we have negative exponential, which in this case have a curve like this, which is a power negative x. Okay? When you have the exponent with a negative sign. Okay? We will just assume that a is positive. We just assume in all our study that a is a positive value. Why? Because negative values gives me some other issues. For example, if I had negative 1, if I need just to put x to be half, what is negative 1 power half? In real analysis, this is not a valid value for, or this is not an allowed value for because I don't have a negative inside a square root. Okay, so let's check some properties of the exponential curve, the positive exponential curve. Let's assume first that a is greater than 1. Okay, what is the domain of that function? What is the domain of that function? The input. Are there any conditions on the input on the x-axis? No. So the domain is just R. The domain is just R. What about the range? The output of the exponential. As you can see on the curve, what are the values of the y-axis? They are just the positive values only. They are just the positive values only, and as you can see here, we have an asymptote on the x-axis. What is meant by an asymptote? It is a straight line for which the curve is approaching, but it never touches it. Okay, the curve never touches the asymptote, but the curve still trying to approach that straight line. Okay, so in that case, the range or the set of outputs is just from 0 to infinity. From 0 to infinity, and 0 is outside that range because the curve never touches the x-axis. But we also say what is the limit or a power negative infinity. What is a power negative infinity? If you let x to be negative infinity, what will be the result? In this case, as long as you make x going to negative infinity, you will just get 0. It is just approaching 0. This is a symbol of approaching 0. What about a power infinity? Assuming a is greater than 1. What about a power infinity? As long as you go to the positive side to the infinity, that value of the curve will just be greater and greater, so it will just be infinity. A power infinity is just infinity. Okay, so that is for as long as you know the curve, you will know all the properties of the function. If we had an exponential, if you had an exponential function but with a less than 1, what will be the curve in this case? It will just be like that. It will just be like that. Okay, so in this case, the domain is just equal to R. The range will just be equal to from 0 to infinity, but in this case, a power infinity will just be 0. Yes, it will just be 0. We'll take this to be 0, and a power negative infinity is infinity in this case. Okay, so this is the case for a less than 1, which, as you have known, we may put the reciprocal power negative x. The reciprocal power negative x, which is b power negative x, like this. If I say that b is 1 over a, this expression, and in this case I will have b greater than 1. So this is just the negative exponential. This is the negative exponential. But when I say a positive exponential or negative exponential, I mean the case for which a is greater than 1. Okay, so we have learned these two forms of the exponential function. He's asking for the domain of this function. What is the domain of this function? So I need here to solve. What is the condition in this case? I just need 1 plus 3 over x to be not equal to 0. To be not equal to 0. So I just need 3x to not be equal to -1. So we just solve when would be 3 power x equal to -1. That would never happen. That would never happen. So that is rejected. So that's why we know that, we always know that this is a positive value. This is a positive value. An exponential, a positive or an exponential in general, an exponential function have always a positive value. It is just like x squared, it is just like root x, but just we exclude the 0 from the range. Okay? So when we add a positive value to 1, that value will never be equal to 0. So logically, that denominator will never be 0. So that's why we say that the domain in this case will just be R. The domain in this case will just be R. Another similar example, if I need to find the domain of root 3 power x plus 3. Also in this case we need to solve this inequality, 3 power x plus 3 greater than or equal to 0. And just as I have told you that 3 power x is a positive value, a positive plus a positive will just be always positive. So that's why the solution of this inequality will just be R. The solution of this inequality will just be R, so the domain will just be equal to R also in this case. Why? Because we learned that 3 power x has a positive value, and adding another positive value to a positive value will give me a positive value. So definitely this, what is under the square root, is definitely a positive value. It would never be a negative value. It would never be a negative value. So that's why the domain of this function will also be R. We have some rules of exponents which you may have studied before. The rules of exponents. For example, if I had a power x times b power x, that gives me ab all power x. And if I had a power x over b power x, that will give me a over b all power x. If I had a power x times a power y, a power x times a power y, that would give me a power x. We add the exponents. We add the exponents in this case. So in the case that we have two similar exponents, we just merge them like this. Or if like in this case, if we had similar exponents, and if we had similar base, we merge them in this case in this way, which we added up the exponents. What if we had different base and different exponent like this? No, in this case we have no rule. We have no rule for this case. We also learned, for example, that a power negative x is just 1 over x. And we may express a power x over a power y. We may express that a power x over a power y is just, instead of adding up the exponents, in this case, we may just write it as ax negative y or minus 1. A power x minus 1. And there is also another case which is a power x all power y. We may express it as a power xy. We may multiply the exponents, okay, and also we may interchange the order or change the order, so we may rewrite it as a power y power a power x. Okay, so these are You should have been studied these rules before. Okay, we will consider our study for a case there is a number called the natural number E, or sometimes it's called the Napier number. This E is just equal to, it is just a universal number, just like pi, for example. This is another universal number which is called the natural number E. The natural number E, which is 2.71 and so on. It has, you may find it in the calculator. This is known to be a base of an exponential function. So this function, we will consider this function to be our basic exponential function. Why that? You will learn onwards our study that it is the only function that its derivative is itself. It is the only function that its derivative, we will know the meaning of this statement afterwards, but we just know that this particular number, which is called the natural number, have special properties for the exponential function. That number gives special properties for the exponential function. That's why we study the exponential function in that form. We study the exponential function in that form. And that E is greater than 1 or less than 1? It is greater than 1. So that's why if I need to graph e power x, it will just be like this. And if I need to graph e power negative x, it will be just like this. Okay? So this is the positive exponential and this is the negative exponential. Okay? And you need to know that at x equals 0, the result will always be equal to 1. Okay? As any studied function, we have studied sine function and its inverse. We have studied cosine function and its inverse. So every function we study its inverse. We have just studied the exponential function. So we need to study the inverse of that exponential function, which we'll call the logarithmic function. Okay? So if I had y is equal to a power x, what is the inverse? What is the inverse of this function? It is called y will be equal to log to the base a of x. Log to the base a of x. And in the case of a natural number which is called e power x, the inverse in this case will just be, we will call it the natural log. The natural log, and we symbolize it as ln. Natural log or log natural. Log natural is just called, we symbolize it as ln. Okay, so this is called ln x. So what is ln x? It is the inverse function of e power x. It is the inverse function of e power x. So what is meant by a log? For example, we know that 2 power 3 is equal to 8. For example, we know that 2 power 3 is equal to 8. Okay? So what is a log? A log is always the exponent. As we have told you before, what is a sine inverse? A sine inverse is an angle. A sine inverse, for example, is an angle which satisfies some condition that its sine will be equal to some number that is inside that sine inverse. So if I told you what is sine inverse of 1 over root 2, sine inverse by itself is an angle. Sine inverse by itself is an angle which satisfies that its sine is equal to 1 over root 2 and some other condition of the restricted of the range of the sine inverse. Okay, so what is the log? The log is the exponent. The log is the exponent. So when I tell you what is log base 2 of 8, what is log base 2 of 8, it means as if I am asking what is the exponent, what is the exponent that I need to put to 2, what is the exponent that I need to put to 2 in order to get a value 8. What is the exponent? So a log is an exponent. As a sine inverse is an angle, a log is an exponent. So if I told you what is the exponent that I need to put to 2 in order to get a value of 8, what is that value? That is just equal to 3. That is just equal to 3. So for example, if I told you what is log base 10 of 1000? What is log base 10 of 1000? So yes, what I'm asking here is what is the exponent that I need to put to 10 in order to get a value of 1000. That value will be what is 1000 in terms of if I written it as 10 power, that is 10 power 3. Yes, so that will be 10 power 3. And what if I told you I need to find log of log base 10 of 0.01? What would you expect that value to be? I need what is the power, what is the exponent of 10 that I need to raise 10 to it in order to get a 0.01. That would be negative 2. If I tell you 10 power negative 2 is just 0.01 and so on. So this is the meaning of the log function. This is the meaning of the log function. It is the exponent for which satisfy the exponent that I need to put to the base in order to get this value. Okay, and so on. They have made tables for the log function or the len function for which values that have non-integer values. For example, what is if I need to solve this equation 2 power x is equal to 5. I don't have an integer known value for x that gives me 5. I don't have an integer known value for x that gives me 2 power x equal to 5. But in this case, they have made tables to solve this equation. This equation will just give me the x will be, x is equal to log base 2 of 5. This x is equal to log 2 of 5, log base 2 of 5. Okay? As I have told you, we learned before that f, when it is applied on an inverse function, gives me x, and f inverse is applied to f of x also give me x. This is in the restricted domain of f, in the restricted, and this is inside the domain of f inverse. Okay, but the exponential function, for an exponential function, is it 1-to-1 or not? Do I need any restriction for an exponential function? No. So an exponential function doesn't need any restrictions. It is by itself 1-to-1. So that's why the inverse is defined without any domain restrictions. The inverse is defined, so these inverses are just defined without any domain restrictions. Okay, and that's why when you apply one to the other, they just cancel the effect of each other. For example, if I say a power log base a of x, a power, that cancels the effect of that and gives me x, and so on. If I said log base a of a power x, so the effect of that is the effect of the exponential. Then I effect with a log to the exponential, so these two cancel the effects of each other, which will give me, eventually will give me x. Okay, and if I write it for the natural number e, I will just write it as e power ln x is just equal to x, and ln e power x is just equal to also x. Okay, we write it as x or any other form that takes the place of x. For example, if I say e power ln anything, will just be the effects of these two will cancel each other to get that thing, and so on. Ln e power something, it just gives me that something already. Okay, so let's graph the, let's make our focus on the natural exponential and its inverse, which is called ln. So we have, this is the exponential function e power x. Okay, to find the inverse, we have just learned to find the inverse, we make a reflection about y equals x. We make a reflection for y equals x. In this case, so if we made that reflection, instead of that horizontal asymptote at the x-axis, we'll have a vertical asymptote like this. And that point, which is also 1, and so on like this. This red function is exactly the inverse of the black function, which is called, this is called ln x. Okay, this is called ln x. So a ln x is a function like this, is a function sketched like this. Okay, let's check some properties of that ln function. What is its domain? What is the domain of the ln function? Well, it will be r positive. Yes, r positive, which is from 0 to infinity, excluding the 0. The domain is excluding the 0. What about the range of that function? It is just r. The range is just r. Okay, now what about ln of 0? Ln of 0 is equal to 1. Ln 0 is equal to 1, and that is a general rule. Log base a of 0 is always equal to 1. Why? Because for any base equal to a, what is the exponent that I need to put to a in order to get a value of 1? That will just always be equal to 0. So a logarithm of a 0, will just always be equal to 1. So ln 0 is equal to 1. Okay, also we have that ln infinity. What is ln infinity? Ln infinity, if you go and make x equal to infinity, you will get it will just become greater and greater. So ln infinity is just infinity. What about ln I have just messed up this rule. This rule, if you put 1, you will get a 0. If you put 1, you will get a 0. The logarithm of 1 will always be equal to 0. That when I describe this rule is wrong. What is meant by a logarithm of 1? Logarithm base a of 1, it is the exponent that I need to put to the a in order to get a 1. What is the exponent in this case? The exponent is just the result of the logarithm is just equal to 0. So ln 1 is equal to 0. But when I ask what about ln 0, when I let x equal to 0, and I let x approaching 0, the len will be approaching negative infinity. The len will be approaching negative infinity. Okay, so these two values are important for us to memorize or to know. Whenever you have known the graph of the function, you will just know these properties. What about if I told you what is len of negative 1? Len of negative 1. Is it allowed to have a len of negative 1? No. We have just known the condition for any len, the domain of any len, that what is inside the len must be greater than 0. It is just like the square root, but we don't put the equal sign with us. Okay? What about the exponential function? Is it even or odd? The exponential, that black function, is it even or odd? No, the black function e power x is neither even or odd. So this is a general function. And also the len x is also a general function. Okay, so either or both the exponential and the logarithmic functions are general functions for us, and they are one-to-one functions as we have learned before. We have rules for the logarithmic function. Log base e x times y is just equal to log x plus log y, and log base e x over y is just equal to log e x minus log e y, log e x power y. There is an important rule in logarithmic functions, log base e of x, that this y can go before the logarithmic function. So that will just be equal to y log base e of x, y log base e of x, and so on. e power log base e of something, these two cancel each other, we get that something, and the inverse, which is log e of e power something, these two cancel each other to get that 1. And you must remember that log base e of x plus or minus y is just that has no simplification. Okay, instead of writing these rules for the logarithmic function, we write them for len, because we just consider the len function for len. We'll just rewrite these rules again. For example, len of a multiplication is the addition of the lens, and if you have a division, it will just be len x minus len y, and if you have an exponent, len x power y, we just take that y before the len, so it will just be y len x. And you need to remember that len e power x, these two cancel each other, that will give an x, and e power len x, these two cancel each other, that should give me the x. What about len of 1 over x? Len of 1 over x, it is just len of x power negative 1. So that negative 1 may become before the len. It will just be negative len of x. It will just be negative len of x. Also, we need to notice that there is a difference between len power 4 of x and len x power 4. What is the difference between these two? In this case, what is len power 4x? It is just len x all power 4. That is a similar expression. Len power 4x is just as saying len x all power 4. It is just as saying len x all power 4. What about this case? In this case, we have just learned that we can take an exponent. Yes, so in this rule, the exponent is on the x, it is not on the len. There is a difference between if you have the exponent to the len itself or if you have the exponent to what is inside the len. This rule is only applied when the power or the exponent is on what is inside the len. So that's why we take that to be like this. But we need to notice that in that case we need to put some additional condition. What would I put here? In this case, x would have been positive or negative. X would have been positive or negative. But when I take that exponent, I remove it and put it before the len. Can I put x negative in this case? No. So that's why when we take the exponent, if that exponent was an even exponent, we just put that inside an absolute value. Okay? So for example, len x squared, what is len x squared? It is 2 len absolute of x. It is 2 len absolute of x. You need to, when you apply this rule, if that y is an even number, if it is an even number, you need to put an absolute. You need to put an absolute on that x. Okay? So in general, we just may say that it is with an absolute, whatever was the domain of the original function. Okay? Now, for example, now let's check that quick example. If he asks me to simplify len of e power x sine cubed x over cosine squared x tan squared x. We need to simplify this expression. How to simplify this expression? It is very easy to simplify expressions using the len. Any function that is considered to be multiplications, and divisions, is treated, when you take the numerator, you take them by a positive value. So you just distribute the len, but for the numerator you put positive value for that len, and for the denominator you put a negative value for that len. What do I mean by that? Let's apply this. Len e power x, that is in the numerator, that is also in the numerator, so it will be len sine cubed x. That is in the denominator, so it will be minus len cosine squared x. And for this one, let's write it as x squared, like this. This is squaring is on the x, not on the tan. Okay, so in this case that will be minus len tan x squared. Okay, so this is the first step in our simplification. Are there any further steps? Yes, there are further steps. What are these? I just check the other rule. In this case, len will cancel the effect of e, so it will give me an x. In this case we have a power. Yes, because this is just ln sine x all power 3. So I may take that power down to be beside ln, so it will just be ln sine x. It will just be ln sine x. And for this case also we'll have to be put like this, so it will be ln cosine x like this. And what about this one? Should I take the square? No, in this case this squaring is inside the tan. The ln doesn't see that square, so I'll just leave it as it is. I'll just leave it as it is. As we have seen that we mostly use the natural logarithmic, which is ln. But what if I had a log with a base 2, for example? Is there any relation between these two logarithms? Is there any relation between these two logarithms? Yes. I can change the base of any logarithm by using the following relation. That log for base a of x is equal to ln x over ln a. Log of base a of x is equal to ln x over ln of a. Okay? How did we get that relation? We can get it easily if we take that value, which is log to the base a of x, and I say that this is assumed to be y, for example. Okay? Then let's take, I want to eliminate this log base a. How would I eliminate it? What is the operation that may cancel the effect of log base a? It is taking the exponent of, is taking the exponential of a. So I take a power both sides. A power both sides, which will give me a to the power y. It will be equal to a to the power log base ax, and these two will cancel each other. These two effects will cancel each other, so that we'll have a power y will be equal to x. So that is exactly the relation. That is exactly the relation that is equivalent to that one. Okay? I've told you before what is meant by log base a of x. It is the exponent that I need to put to the base a so that I get the value x. That is exactly the same expression or the same interpretation that I have said about the how to understand the meaning of the logarithm. Okay? Now I will just change the base. I will just change the base for this equation. How would I do that? Let's take ln both sides. Ln both sides. Or any logarithm with any other base. I may take the logarithm for any other base. If I take ln both sides, for example, it will be ln a power y. It will be equal to ln x. And ln a power y, these, I will apply the rule that says that I can take that y besides the ln. So that's why y ln a, y times ln a will be equal to ln x. And that's why that y is exactly ln x but over ln a. Okay? So what I've done here, that I have rewritten that expression in the exponential form by eliminating the effect of the logarithm first, by taking a power both sides. Then I have applied a logarithm with another base to the equation. I applied the logarithm of another base to the equation so that I can express y again, but with that new logarithm or the new base. Okay? So whenever I have logarithm base a of any function, I can transform it, or I can write it as in terms of ln, for example, or any other. If I need to say log to the base 2 of x, that is equal to ln x over ln 2, and that is a constant, that is a number. That is just a number. So it is just as if there is a scaling, to the ln x I have. If I had, for example, ln 2 of x, that would be equal to what would be the relation to log base 10 of x. And by the way, if I say just log without mentioning the base, it is meant to be 10. If I said log without mentioning the base, it is meant to be 10. Okay? In that case, log base 2 of x, it will be equal to log base 10 of x, but over that same operation but to that value. So over log base 10 of 2. I'll just rewrite it again. Log base 2 of x. I need to write it for the base 10. To write it in the base 10 terms of the base 10, we just divide it by that same operation, log base 10, but for the initial base. Okay, so that will be the relation to that we can interchange between bases, or if I need to change the base. Okay. Also, we can, for any exponential function, for example, if I had 2 power x, I've told you that it is better for us to express exponential functions using the natural number, which is e. So we also need to express that exponential function in terms of the base, which is e. Okay, so we changed any base for the logarithms from a to ln, and we also need to change any base for the exponential function to the exponential base. How would I do that? That is easy also. Look at this number, which is 2. I may rewrite that 2 as follows. What if I say that 2 is just equal to e, but to the power ln 2? E, but to the power ln 2. Okay? So that 2, yes, that is correct. So I may say that 2 power x is just e power ln 2 all to the power x. And that's why 2 power x is just e power ln 2 times x. Okay? So I may change the base for an exponential function to the natural base, or to the e, that the natural number that we know. Okay? Also, one of the things that we may need to simplify, for example, I may have an expression like this: e power x plus 3 ln x. How would I simplify this expression? First, we have the rule of exponents. If I have a sum of exponents, I may write it as e to the power x times or plus times e power 3 ln x. Okay? We know the rule that a power x plus y is just a to the power x times a to the power y. These are the rules of exponents that we had learned before. Okay, is there any other simplification in this expression? Yes, whenever I have an e and inside it we have ln, we may try to make another simplification. But how would I do that? In order for e to eliminate the effect of ln, they must be in direct relation, with no any other separator between them, with no any number between them. It just must be e to the power ln of something, without any other thing. But here I have 3. It prevents me from eliminating the effects of e and ln. But would I use the properties of ln to make it in that expression? Can I do that? Yes. If I take that 3 to be the exponent of the x inside the ln, so that will be e to the power x, e ln x to the power 3. And in this case, yes, the effect of that e eliminates the effect of that ln, and the result will be e to the power x times x cubed. or x cubed times e to the power x. Okay, so that expression is just can be simplified in that form. Okay, I need you to try to simplify this expression. Okay, try to simplify this expression. And we have 3 minutes. Okay, just check with me your answers. Now we learned that if I have a len with products and divisions inside that len, the simplification is easy. We just distribute that len on these terms. So we'll have, but for the numerator the lens will be with a positive sign, and for the numerator the lens will be with a negative sign. So in this case we'll have len 3 power root x plus len of cubic root of x plus 1 minus, because this term is in the denominator instead of the numerator, so in this case it will be len sine power 5 x squared minus also len of sine inverse root x minus also len of x squared plus 9. Okay, so this is the first simplification. Are there any further simplifications in this expression? Yes, for this one we may take that power to be beside the len. Also for this case we may take that to be beside the len. What is this power? How would I describe this power? This is exactly x power 1 all to the power. What is the cubic root? How can it be expressed as a power? It is 1/3 or 1/3. Okay, so I just take that 1/3 to be beside the len. What about this one? Which power would I take beside the len? 5 or 2? Or would I take it 10? So I'll take just the 5. I will take just the 5 to be beside the len. What about the minus 1? This minus 1. Would I take it to be beside the len? No. The sine inverse, we learned before that for a sine inverse, this is not a power. This is just a symbol for the inverse operation of the sine. Okay, so this is not a power. So I may not take that exponent to be beside the len. What about this expression? Could I write it len x squared times len 9? Or would I take it len x squared plus len 9? Which of the following is correct? Either are correct. Yes, neither is correct. So why? Because len of a sum is not simplified. Len of a sum is not simplified. Remember, there is a difference between len of a sum and a sum of lens. If I have sum of lens, yes, they are len of that times that one. But len of a sum cannot be simplified. That's why I will leave that as it is. I will just leave it as it is. Okay, so let's write the final expression. It will just be root x times ln 3, and that is a number times that root x. I will have here 1/3 of ln x plus 1, and in that case I will be 5 ln sine x squared, and this I will just leave it as it is, and for the last term I will just leave it as it is. Okay, so that is the simplification of this expression. This is the simplification of this expression. Now he's asking me for the domain and the range of this function. The domain and range for this function. Okay, we have learned to find the domain of a ln. What is the condition of what is inside the ln? What is the condition? This is just much like the root, but without the equal sign. So we just take what is inside the ln, and make it greater than 0 instead of greater than or equal to 0 like the root. No, we'll just make it greater than 0. Okay, for this case I would take any odd powers. I can take the root without consideration of the order or whatever, so it will just be x over 2 over 3 just greater than 0. Okay, taking roots doesn't change the order. Okay, so in this case it will just be x minus 2 greater than 0, and it means that x is greater than 2. So the domain is just 2 open and to infinity. The domain is just 2 open and infinity. What about finding the range? To find the range, we studied 3 methods to know the range. The first method is by the inverse and finding the domain of the inverse. That is one method. What are the 2 other methods? We learned by sketching. If I sketch that, this function is sketchable because I have known how to graph ln x. By using transformations, I can sketch that function, so that I can, by using the sketch, after sketching the new function, after transforming ln of x, I can know the range from the sketch. That is one way. Also, with another way, we can know that by the inequality method. What is the inequality method? And that is the fastest one in this problem. What is the inequality method? The inequality method is that we know that a ln, what is the output of a ln? The output of a ln is r. So a ln x is just from negative infinity to infinity. Ln x in general is from negative infinity to infinity. So whenever I have a function with an odd power, a linear function, a cubic function, a fifth power function, and so on, that will not change that inequality. So that one will just be, it will just satisfy the same inequality for the output of ln. Now I just need to add 1 to that inequality. I will just add 1 minus infinity, 1 plus ln, then 1 plus infinity. What is 1 minus infinity? It is just adding numbers to infinity will not change the infinity. So in that case, I will just have that f of x will just be from negative infinity to infinity, which means that the range of f of x is just equal to r. The range of f of x is just equal to r. So I've solved the equation using the inequality method. Okay, whenever I have a function, for example, I know that we have learned before that sine inverse is from negative pi over 2 to pi over 2. We have learned that before. If I put here a function, a linear function, for example, if I put x 2x minus plus 1, that will not change that inequality. Why? Because it has, now this is the input of the sine inverse. It will cover the output of that function, which is exactly the input of the sine inverse. It will just cover the whole domain of the sine inverse. So it will not change that inequality. Okay, so I will have this. Also, for if I had a cubic relation, also a cubic function will cover the whole domain of the sine inverse. We know that the sine inverse has a domain from negative 1 to 1. Okay, the output of x cubed will just cover the whole domain. So whenever I put a function inside sine inverse which covers the whole domain of the sine inverse, it will just satisfy the same inequality as it is. But if I had a function, for example, like this, sine inverse absolute x, that function has a range, a positive range. That function has a positive range, an output, which is exactly the input of sine inverse. So what you are putting inside the sine inverse are just positive values. So in this case, I can't say that the output will be from negative pi over 2 to pi over 2. I cannot say that in this case. Why? Because this function is not covering the whole domain of sine inverse. This function is not covering. No, you are just taking, for example, if we graph the sine inverse function we have learned is like this. No, it was like this. It was like this. That is the sine inverse function, and you need to review the sketches of the standard functions that we have learned. That was from negative 1 to 1, and here is from negative pi over 2 to pi over 2. Okay, that is the sine inverse. Would any input to that function give me a negative input to the sine inverse? Never. Okay, so in this case I will never get that value. So that's why when I tell you that whenever the input function is covering the whole domain of sine inverse, is covering its output, its range is covering the whole domain of sine inverse, in this case we may rewrite the inequality with that new function inside. Okay, so that is how to use the inequality to find the range. What about using the standard method, which is the inverse? Let's try it using the standard method. We know here that y, we have here y is equal to 1 plus ln x minus 2 over 3 all over power 5. Okay, so we'll interchange x with y. X equal to 1 minus ln y minus 2 over 3 all power 5. We need to solve it for y. So it will be x minus 1, or we may write it 1 minus x, and that will be positive ln y minus 2 over 3 all power 5. Now I need to eliminate the ln. How would I eliminate the ln? By taking e power both sides. Okay, I'm not telling you multiplying by e. No, it is taking e power both sides. If I have a side equal to another side, then e to the power this side will just be equal e to the other side. So in this case, I will just say e to the power 1 minus x, e is equal to e to the power that side. So that will be e1x equals y minus 2 all power 3 all to power 5. I'll just eliminate the power 5, that is a one-to-one function, so we don't have a restriction on domain. For example, I will just say that y minus 2 over 3 will just be equal to this, the fifth root of this, the fifth root of this function. And I can apply the rules of exponents in order for it to be 1 minus x all power 4 over 5. So in this case, y, or the inverse function, will just be 2 plus 3e to the power x minus 1 over 5. Okay, so that is the inverse function. That is the inverse function. That is the inverse function of that one. What about the domain? So the domain of that inverse is just the range of the original function f. What is the domain in this case? Do I have any restrictions on the input of an e? No. E power x has a domain of r. So in this case we will have no restrictions on this function. That's why the domain will just be, the domain of f inverse will just be equal to r, and so is the range of f, and so is the range of f. So that we have just deduced the same result but by another way. If I have an equation, or before saying these equations, let's check that example. Check is if it's even or odd or general. If I have this function f of x is equal to ln of root 1 plus x squared plus x. Now if I check this function with the rules that I've learned, this is odd. What about this? What is inside the root is 1 plus x squared is even. I have even plus even, but it is inside a root, and the root is general. If I have a general function and inside it I have an even function, what would be the result of that combination? It will just be even. So what is inside the ln? Even plus odd, it is just no, even plus odd is just general. Even plus odd is general. Okay, so I have now ln of general. What about ln of general? Is it general? No, I have no rule in this case. I have no rule for f of general. So how can I manage to know the case? I have two ways, either by using simplifications. I try to make simplifications on the expression I have, or another way is to just try by the basic method, which is interchanging x with negative x and checking the result to be either f of x or to be minus f of x. In this case, I will just make a simplification. How would I do that? I will multiply by the conjugate in the numerator and the denominator. Okay, I will just 1 plus x squared minus x and root 1 plus x squared negative x. I didn't change my problem, but in this case, whenever I multiply a number by its conjugate, for example a minus b times a plus b, these are two conjugate numbers, what would be the result? It is squaring of the first minus squaring of the second. Okay, it is just the rule of difference of squares. It is just the rule of difference of squares. Okay, so if I have this multiplied by its conjugate, it will just be squaring of the first and it will just be, I will take the root, then minus squaring of the second, and the denominator will be as it is, 1 plus x squared minus x. So what is the numerator in this case? I may cancel x squared with x squared. So I will have ln of 1 over root 1 plus x squared minus x. Now if you look closely at this expression and that original expression, I will just remove these. What do you see the relation between these two? These two expressions. I'm just having that expression is exactly no sorry, I will not solve it by using simplification. Will not solve it by simplification. We just use the original method, which is f of negative x. I will just check f of negative x. Okay. So what is f of negative x? F of negative x, I will just change every x to be negative x. So in this case, that will be, I'll just rewrite it. So f of negative x will just be ln of 1 plus x squared minus x. Okay. This expression may seem not equal to f of x or minus f of x, but if you multiply by the conjugate in the numerator and the denominator like this, okay, let's check this way, that will be plus, that will be plus. Okay. If I just take that function f of minus x and take what is inside the ln, and I multiply by the conjugate in the numerator and the denominator. Okay. In this case, I will just get that expression. And I've learned before, what is ln of 1 over something? It is just ln of that power negative 1, which is negative ln of that something. So whenever I have ln of 1 over something, it is just the negative of that ln. Okay? So I may just tell you that this is negative ln of root 1 plus x squared plus x. And this is exactly the original function. That is exactly f of x. So I've just deduced that f of negative x is just equal to f of x. It's just equal to the negative of f of x. It's just equal to the negative of f of x. So how would I classify the function in this case? If I have a function for which f of minus x is equal to the negative of f of x, it means that the function is odd. So this function is an odd function. So this example is a known example that you may not get the idea directly when you look at the function, but you need to study it. Okay, so this is a studied example that you need to study by itself. Okay, I need you to check if this function is even or odd. Ln of 1 plus x over 1 minus x. Check this function if it is even or odd. Now this, what is inside the len in this case? It is general. So we had a case just like the previous example. And I have no simplifications. Maybe I write it like this, but this will not change the complexity of the problem. It will just be, this will be general also, and this will also be general. So it didn't change. So I have only one way to check if it is odd or even. I will just check f of negative x. F of negative x, in this case, it will just be 1 minus x over 1 plus x. Is there any relation between this expression and the original function? Yes. What if I take the reciprocal of what is inside the len? What if I make a reciprocal of what is inside the len? I just take a negative sign and I make the reciprocal of what is inside the len. In this case, this will just be negative of f of x. So we have just deduced that f of negative x is just equal to negative f of x, which means that f is an odd function. In this case, f is an odd function. Now we need to find the domain of this function, and we learned before how to find the domain with a function with a len. We just take what is inside the len and make it greater than 0, and we solve the inequality. Okay, so I'm solving. I need to find when would e power x be greater than negative 1, and you need to remember that e power x, just like x squared, just like root x, just like absolute x, all of these are known to be positive or 0. But in this case, we have e power x is positive only. E power x is only positive. So I'm just asking you, when or what, for what values of x would that positive expression be greater than negative 1? When would that positive expression would be greater than negative 1? It will be for all allowed values of x. All allowed values of x, which is, in this case, will be just r. So the domain of this function is just r. Why? Because what is inside the len, you are assured that it would be positive. You are assured that it would be positive. This is a positive number and this is a positive number, and adding positive numbers to each other will just give me a positive number, and it will never be negative. What about, is there a difference between these two functions, 2 len x and len x squared? If there is a difference between these two functions, yes. These two functions are different. We learned before that when we take that 2 beside the len, that will be 2 len absolute of x. Okay? So what is the difference between this function and this one, that other function? These two functions may be equal in some range for x, or in some interval of x, but not all of x. Why? Because the domain of this function is that x is greater than 0. What about the domain of this function? The domain of this function is x squared greater than 0. I need that x squared greater than 0. What is the solution of this inequality? I just know that x squared is positive or 0. So this inequality will be just satisfied except for one number, which is the 0. 0 is not greater than 0. 0 is not greater than 0. So what is the domain of this function? It is just r minus the 0. The solution of this inequality If I told you what is the solution of this inequality, greater than or equal to 0, that will be r. But if I told you x squared greater than 0, I just need to eliminate or to exclude the value for which that side is equal to 0. So this is the difference between these two functions. This function has a domain of r minus 0. This other function has a domain of x or 0 positive, r positive. So these are two different functions. But they may be identical for some interval of x. For example, for x greater than 0, these two functions will just be equal. Now if I need to find the domain e power x minus 3. We just learned that for this we take e power x minus 3 greater than 0. So I need to solve this inequality. E power x greater than 3. I need to eliminate the effect of e. I eliminate it by using len. Yes, I will just take len both sides. But what about len? Does the len change the order or keep the order? Would I change it or keep it? How would I know if a given function changes the order or keeps the order? This is the rule. If I have an increasing function keeps the order. If I have, for example, a is less than b, then for the f's, for the images of these inputs, we'll have just the same order. I will just have f of a less than f of b. It is obvious, f of a will be just less than f of b. But when I have a decreasing function like this, and I have a less than b, what about the f's of these a and b? You will find that f of a would be greater than f of b. Why? Because the f that you are operating on the sides of the inequality is a decreasing function. So I need to know, what about applying len both sides for this inequality? Is the len, it is the same as asking, is the len increasing or decreasing? We just learned the graph of len. It was just like this. Is it an increasing function or a decreasing function? It is an increasing function. So it just keeps the order of the inequality. So I may just take the len of both sides without any changes for the inequality, as if it was like an equation. Okay? So in this case, I would just say that len e power x greater than len 3, and x will just be greater than len 3, and that is exactly the domain of the function. That is exactly the domain of the given function. If I have this equation, I told you solve the equation. When I have an equation with lens like this, we may use the properties of len to simplify the problem. For an equation, we like the equation to be len equal to len something. Okay? So what about this side? Could I write it in another form? Yes, if I have adding two lens, is just len of multiplying what is inside both lens. So that will be just len 2x plus 5 like this. Now, would I cancel these lens? Actually, it is yes, the final result will be as if they were cancelled. But what I have done here, that I have taken the exponential both sides. Okay, the correct mathematical operation that I have done here, it is not said that I have cancelled lens. It is not said that I have not cancelled it. I just say that I have taken the exponential of both sides. So in this case, it will just be 4x minus 1 will just be equal to 2x plus 5 like this, and I just need to solve that equation. That equation will just be x will be equal to 7 over 6. Whenever I solve an equation with lens like this, like these, I need to check it again in the original equation. Why would I do that? Because maybe I get a value for x which makes what is inside the len to be negative. Maybe I would get a value of x which makes what is inside one of the lens to be negative, and in that case that x would be rejected. Okay, so I need to check in the original equation, if it is an allowed value for all of the terms or not. If it is allowed for all the terms, then it is okay for to be a solution for the problem. So the solution set will just be equal to 7 over 6. After checking that, all that will be positive and that will be positive, so it is a permitted value of x. If I need to solve this equation, len of x squared minus 1 equal to 3, I need to find x, so I need to eliminate that len. Okay, how would I eliminate that len? By e power both sides. In that case, that will be x squared minus 1 equal to e power 3. That means x squared be power 3 plus 1, which means that x will be equal positive or negative e power 3 plus 1. Okay, so that is the solution of this equation. Now let's check this. If I need to solve this equation, len x will be equal to len 2 plus len 5. Would the result be 2 plus 5? No. What would be the correct result? Yes, it will be, yes, I need to eliminate the len. So I may take e power both sides. I need just to emphasize that you are taking the side as a whole. So it will just be the other side will be len 2 plus len 5. That will be x. For this term, if I need to simplify this expression, yes, it will be len. If I had two lens added, I may just write it to be len 2 times 5. This is e operating on a len, so that will be just be 10. That will just be 10. X for this case will be 10. That is the solution of the equation. What about this one? Could I say x will be 2 plus 5, or would it x be 10? What would be the result in this case? What would be the result in this case? Neither is correct. Some of the students may just tell you that I will take len both sides. So just say that len of that side, which will just be x. Len of this side, they just write it as 2 plus 5. Actually, that is not the case. When you are taking len of that side, what is len of that side? It would just be written as len of 2e power 2 plus e power 5. Could I simplify this expression? Could this expression be simplified when I have a len with added terms? I can't. I may just simplify with products inside the len, but not a summation of terms. Okay, so that is the solution of the equation without further simplification. There is no further simplifications in this number. This is just as it is. It is just len of e squared plus e power 5. Okay.